I haven't done it yet.
My rings are not. Actually, I might take this one. Okay. Okay, guys, so I'm gonna do experiment 1 first. One of you turn on your camera for me. This is lonely. Please. This is really lonely. Yay! Please. Okay. So, I'm just gonna read through it. Sorry, but okay. Okay, so 1 dropper of. Gotta wear my goggles. Of SFE. Mr. Jackson, can you help me find this chemical?
What is it?
SCN plus.
That's what you're making.
Oh, that's what I'm making?
Mm-hmm.
Oh, okay, my bad. Okay. So this is in dropper 1. How do you get these out of here?
How do you what?
Get this out of here. Okay, there we go. I got it. Okay, 1 drop. Okay, of that. And 1 drop of SCN. Woo! Look at that, baby. Okay, so I made FeSN plus 2. These chemicals. The color of this mixture is too intense to use as it is. So dilute it. This mixture with within 1 inch of the top of distilled water. Mix well. Describe the appearance of the solution. Okay, so I'm gonna mix it until it's transparent. That's not enough. Okay, I think this is transparent. You can see through it. Give it out a little more. Okay. There we go. Okay, describe the appearance of this solution in the test tube. Okay, write down it's transparent.
Would we say it's transparent and translucent?
I have no idea. Is translucent the same as transparent?
Translucent is when light can go through it, so we don't really know.
Yeah, I would just write transparent and like orange or whatever color it is.
Yeah, it's like, I would say like a blood orange. Okay. So now I'm going to divide this into 4 small test tubes. Okay. How the heck am I going to do this without spelling it? Mr. Jackson? So I divide this into 4 test tubes. How do I do it without spelling it?
I'll pour it into a clean beaker then.
Oh, okay.
You ready?
Yeah. Okay, now I got to clean another thing.
That's what yours looks like?
Yeah, mine looks like this. I might dilute it. Well, if it's transparent.
Yeah, you know they always hold it up to the and they're like,
Okay. It's been really bad. Okay. Sure, everything's clean. Alrighty.
I think you should go further. You gotta flick it.
Sorry, guys. I'm trying to do this as efficient. Because doing labs when it takes forever stresses me out. I'm trying to evenly do this. Okay, ooh, that's like. Okay, this is good.
Guys, remember, we're not pouring any of this down the drain. We're pouring experiment 1 into here, 2 into here, and 3 into here.
Okay. All right. Small test tube 1 will be your standard. Okay, this is my standard. I'm putting it in the front row. Don't let me forget that. No changes will be made to it. It will be used for comparison purposes. Place it in your test tube rack. Test tube 2, add 1 dropper slowly of FeCl solution. Okay, this is test tube 2. This is FeCl3. And then if you want to look on the the equation, it should be like either we're adding more product or adding more reactants. We can write that down. So if we're adding more product, then we're using up more product.
Make sure the beaker's clean.
Okay. Okay, 1 dropper. Okay, that's what it looks like. Pretty orange, still a little transparent. Okay.
Is that
So,
tube 2?
yeah.
Okay, so we should say transparent and darker orange, like.
It's a pretty dark orange, almost like a cherry red. Still transparent, dark orange, I'm gonna say cherry red.
Wait, was that like,
Hi, Lily.
was that forward because like we added something?
What is it on the, is FeCl3 on the products or reactant side?
On the
It's
equation.
on neither.
Oh, it's not on either. Weird. Mr. Jackson, FeCl3 isn't on either, so like it's not in the equation.
Net ionic equation.
So is it Fe?
Yeah.
Oh.
That's why the first page is so important. I took this read that several times.
Yeah, I did.
The very first page.
Oh, I see it. Okay.
It has all the equations that you'll need.
Okay. Fe3 plus is FeCl3. So it's on the reactant side, so we're adding more reactants. So it's a forward reaction. It's producing more product. That's why it's getting more red. Cherry red. Produce more product. Very red. Test tube 3. Add 1 dropper of case. Okay, I would say this is even darker red. Yeah, it definitely is. It's like a really dark maroon color.
And it looks opaque, so we could say something about that. Or can you see through it?
No, I can't see through it. Okay. Oh. Dark maroon. Okay, and then we're also adding more product on that side, so we're producing more. No, we're adding more reactant, so we were producing more product.
Yeah.
Wait, say that again. I'm sorry.
No, you're good. We're adding more reactant, so that means it'll be a forward reaction. So we're gonna use up more reactant and produce more product.
Yeah, but we don't have to write that down anywhere yet.
I'm just writing it down just in case.
I think it's on page 4 of the thing, like where that's where we write it down. That's where I've been writing it down.
On the experiment, like where the things are.
Oh, in the system, what causes it to be red color?
Yeah.
What else is there for me to move?
Okay, AgNO3. Okay, so I'm gonna add it dropwise until a change becomes evident. So I'm just gonna keep adding it until. So this, when I add this, it removes less reactant. So then it'll be a reverse reaction. So it should get less red. It says that on the bottom, like the note part. Okay. Oh, wow. Ooh. It's cool. It looks like one of my crystals I have. I really like it. Okay, that like was an instant reaction. Okay, but it's not see-through at all. It's really cloudy, and it has like a tiny hint of really, really light yellow. So it's cloudy, very. I would say it's very like white mixed with yellow. I'm just saying white plus yellow. And at the bottom of the note part in all caps, I said it has less reactant, comma, reverse reaction, comma, produce reactants, which is like, go back, obviously. Okay.
We're supposed to have a note part?
Mine does.
Mine doesn't.
Let me see if I can.
I'm confused. Do I have the wrong?
Do you see that?
I think it might be. Oh, yeah, we have that, but it's like not like anything we have to write.
Yeah, it just says note with exclamation marks.
Yeah, that I just wrote it below that, just in case.
Oh,
It's not anything you have to have down. These are all just like notes that I'm writing, so I get a good grade.
Over $1 million. Would you
Okay.
I wouldn't have.
So
Learn from this too.
these are for, and I'm gonna go dump these out, and I have to wash them again.
What?
Okay.
Yes. So experiment 1 goes here. Here's your hot bath and your cold bath. So try to make sure that you social distance over here. This is better than either everybody having to make one.
So what would you experiment that one low in the Actually, this experiment. Oh, right. So what do we play?
I was like, Mia, do not give me a heart attack here.
What did she say?
She was like, this
is only for experiment 1, so I think like.
Yeah, that's 1, 2, and 3.
Yeah.
That's funny.
and I was like, oh my god,
Wait, oh, this we broke them out with.
we have to do it all over again.
Don't put them in the sink, put them in.
Experiment
Yeah,
1, yeah.
don't dump it out. Put it in that like thing that has.
Oh, yes. We got him to get the slime is rejected. Like he walked in, I was like, can you get that? And he goes, yeah. He popped right in. He said tastes like applesauce with chocolate. Yeah, it's like applesauce. And then he went back for another bite. It turns what are we gonna do? Hey, oh wait. This one, oh, that's gonna leave it there. Maybe the first one before I close it. So to the 07 NA. Sometimes you do haircut. Oh, yeah. I told Maddie to say
Okay. Gotta dry them.
It turns like apple juice color. It turns like yellow what? I mean, you don't expect me to be the one that. Okay, so for experiment 2, your number 2, so like it turns into a bright yellow.
Okay.
And then for number 3, say that it turns like yellow. Number 2. And also there was like
Okay.
Oh, yeah. Oh, yeah, sorry. Oh, no, sorry.
yeah. No,
Okay, will you guys read through 2 just in case? Experiment 2, just in case.
What was test tube 4?
Huh?
What was test tube 4?
Test tube 4 was the one where it like went really white.
I thought that was test tube 3.
No, test tube 3 was the opaque dark maroon color. Because remember, I had one test tube where I didn't do anything to it.
Oh, and that was test tube. No, but then what's test tube 2?
Okay, test tube 2 is the one where it's still transparent. It was a cherry red, and it
Oh,
produced.
okay. I think I didn't see test tube 3.
Gotcha. Wait, what'd you say?
I don't think I had test tube 3.
Oh, okay.
If it changes a little bit, I have some more to
Okay.
How are you?
Alrighty.
Waterman, you leaving 140 tonight?
Okay,
You
so
got
this
soccer or
is.
something? Vaccine.
Okay. CR04. Okay. So this is K. This is CR04. It's really like pea colored, to be honest. Like, like really like even neon yellow, I would say. Okay. And then. And then this is CR207. This is like again kind of like a bloody orange-ish. Let me bring you in. So here, I'm gonna write that down.
Wait, so okay, what color was test tube 3?
Test tube 3 was an opaque dark maroon, and it produced more product. Because we added more reactant.
maroon.
Yes.
Yeah, I don't think I need to write that down for what I observed though.
Okay. Okay, I said this was CR207, right? Yeah. Yeah, okay. So this is like, I would honestly say even like a peach color. Okay, so like peach, right. Okay, and then this is like a pea, like honey kind of bee color. Okay. Place 2 droppers of this in a small test tube. Okay. So I'm gonna place 2 Oh, these are always so jammed. And then I'll add NaOH. There we go. Okay. So that's a 1 drop. And 2 drop. Okay. Now I add NaOH dropwise until I see a change occur. Okay, I'm gonna add another one. Okay. No, barely.
Yeah, mine, I had to add like a lot.
Okay, really?
Yeah,
Okay.
but I think it's supposed to turn yellow.
Okay. You put the 07 one.
Yeah.
No, wait. Yeah, you put the 07 one in. And then you add the NaOH one until like a really big change occurs. So I'm gonna add one more and see. Okay, yeah. So look at the difference. This honestly turned into this, I would say. Oh my god, yeah, look how identical they are. Okay. So this is the change. I would say it got a lot less peachy and a lot more pea yellow. And it looks exactly like, if you want to write this down, it looks exactly like CR04. Yeah, okay. Okay. And for the note, sodium hydroxide removes hydrogen atoms from the system. So it removes the hydrogen. I'm just thinking of this from like a, so it removes products, so it goes reverse, so it produces more reactants, if that makes sense. Okay. Experiment or dropper 2, CR04. So that's the pea colored one. In a small test tube. Okay, and then I'm going to add HCl until a change is noted. So this is drop 1, drop 2. Okay. This is HCl. These are really jammed. I know I say that every time, but okay. Oh god. I know it's so hot. Okay. I'm dropping it dropwise until it changes. Oh wow, that was fast. Okay, so that got really orange really fast. Or honestly, like a yellow orange. I'm gonna add another one.
Anybody else low on isopropyl alcohol?
No. Okay. So look at that. Do you think I need to, Mr. Jackson? Do you think I need to still add more HCl or no?
What was it supposed to do?
It was supposed to, I don't know. Okay, hi, sorry guys. Okay, so hydrochloric acid adds hydrogen atoms to the system. So it produces more product, or no, it makes more product. So it's a reverse reaction, so it'll produce more reactants. So it should be producing this in a way. So I'm gonna keep adding more. I'm probably gonna add like 2 more. I think that's good. Okay. This is what it was supposed to look like. And this is what it came from. I'm gonna add 1 more, just because like I feel like I'm doing something wrong, but I didn't do anything wrong. Okay. So that it's transparent, very transparent actually. And it's kind of like a really, really dark yellow. Okay.
So, you guys got all the answers and everything?
Okay.
Like for all the experiments stuff?
That's experiment 2. I'm gonna go wash out my test tubes.
So, you guys have all that?
I'll be back for experiment 3. That's the one I'm a little scared about. So read through it, please. I'm sure it'll be fine, but.
So you have to drop that and you add water slowly until it's right around the
Okay. I just have to clean these 2. Yay.
What did you guys write for the 2B and 3?
So,
Wait, say that again. I'm sorry.
What did you write for the 2B?
For experiment 2 or experiment 1?
For experiment 2. For experiment 1, there is no like 2.
You could say like more, it produced more reactants, so reaction is favored.
Oh, because okay, so we're adding more. What are we adding to the?
It's supposed to be a thing.
I think I figured that out.
It's supposed to be a buoyancy machine.
okay, cool. We're moving over here. You want me to? Greg, you want me to?
So since when you added the NaOH, it what?
It removed the hydrogen atoms, and that was on the product side, so it removed the products. So then it would be a forward reaction and produce more product.
Oh, okay. So I can say the color changed to the color of the CrO4 -2 solution because the reaction favored the forward reaction, so it produced more products.
Yes. Okay, place a few crystals of COCl2 in a large test tube. Add 2 droppers of isopropyl alcohol. There should be a small amount of solid remaining at the bottom of your test tube. If there is no apparent solid, add a few more crystals. If the solution is not a pink color, add water dropwise until the solution turns pink. Okay. Sounds good. Okay, so here are the crystals. I don't know if you can see that. You guys in the light again. So, okay, I'm gonna add a few.
Oh yeah, now it's like a pink color, it's like a dark.
How do I add these? Wait, how did you guys add the crystal? I don't
There's
know.
a scupula.
Oh.
You gotta dump the crystals onto the scupula.
Okay, thank you.
It's a very like roundabout, complicated thing. You can't stick the scupula in there 'cause it's-
Yeah, then you add water.
Oh, you can't? They won't come out though. They're like stuck.
Don't have too much soap.
Put the cap on it.
Yeah.
Shake it up.
Oh yeah, it did. Yeah. Okay.
Probably rinse my hands off.
Maybe. Okay, here are my, I can't really show you it to be honest. Yeah, there I can. Those are my crystals. I would say that's a good amount. If not,
What was that?
It has bubbles in it. Maybe.
okay.
Yeah, it's got bubbles.
Those are my crystals. Please. Okay. Now I need isopropyl. There we go. Here's my isopropyl. Can I add 2 drops?
Were you able to get some out of there?
Yes. Do you think that's enough?
Yep.
Okay.
And
One.
this is gonna be Monday, right?
Here's one.
I think so, yeah.
Ooh, it's blue.
Do you have anything else we have to work on? Oh,
And
yeah, Monday also there's a lesson. We want to get through acid bases, we have to have a lesson on Monday. So we have video lesson.
How long?
and there is some solid at the bottom. It's like dark blue.
What?
That'll be a video.
Wait, what did I do?
No, I think you're right.
No, it says it should be pink.
So it was.
No.
So was it
Oh, uh-oh, hold on.
Is that when you have water?
No, Olivia, I think you're fine. You just have to add water with the pink. I mean, the pink turns water.
Okay, I have to add water. I thought that was just, is that what you said? Okay, my bad. I thought you did that just in case it didn't turn pink. Okay.
That would be an interesting story, right?
Yeah, maybe.
Any damage caused that you purchased?
You're good, Peter, you're right.
Yeah,
Okay.
I actually got attacked by a dog.
That's like
I'm
a
just
light,
confused
a
why
very
it
light.
turned pink.
Wait, what?
I'm just confused as to why it turned pink.
I don't know. We can figure that out. I know, I'm just trying to finish it, to be honest.
Okay, wait. So I'm confused about like 3B because like it didn't turn the color of the other one like the other one did. So like if it favored the reverse reaction, should I just say like it changed to closer to the color of the other thing because
Yeah,
it favored the reverse reaction, so it produced more reactants?
yeah. Yep, that's good.
No, it is, because that's what we added.
You could have
Both
moved
of
it.
those are in.
It's not like I have a magical move that I gotta do.
Okay, I'm gonna go put it in the hot bath. I'm actually gonna take you guys with me. Oh my god, I'm fine. These are so stressful.
So, what change happened? There was more products, or no, more reactants to products,
Taking you guys with me. Wait,
right?
just gonna make sure. Until a color change is noted, what happened to directly around the crystals as it heated? Okay. Oh god, I definitely just ran into it too.
I'll just use the right foot. Sorry.
Do I like dip it?
I'll call you back.
Yeah, you put it in it and you gotta move it around. So you can see what actually colors. So yeah, now it's like dark.
Yes, exactly.
Okay, so there's the green when it was put in the, or hot water turning bluish. When it was put in the cold water. That's more darker, pinkish.
Oh.
Bringing more.
So yeah,
Actually, wait, the second
we
part.
did.
Well, yeah, no, if you look, it's doing FE plus.
Okay. This is what happened. It darkened a lot around the crystals and it turned like a
You put it
purple.
in the cold one?
Yeah.
Yeah.
Hold on, I'm actually gonna get my lab.
And then for the one below, it's gonna be more products added, so therefore, what's on for you to say there's more. Yeah. It's the exact same.
Okay, now it's in the ice bath.
I think I understand it now. Okay, so basically with the isopropyl, whatever we put it in, when the alcohol and the water mixed, it turned it to the color it was. And then when you heated it, all of the water evaporated, causing it to go back to its original state.
Oh.
You like CJ?
Kind of. It got less watery. It got more foggy. Thank you, Raylan. That was good. You're so smart. Okay. This is it after the ice bath. Oh, it's getting on my computer. But like you can see it got a lot more foggy and honestly a lot darker at the bottom. It's kind of like a plum. I know. I'm loving these descriptive words with colors.
So when the alcohol and water mixed, it turned red and pink.
David, that sounds pretty smart. Right?
Sorry, Margaret, I didn't hear that. I'm just gonna.
Wait, say that again, Margot?
So you're saying that when they added the water to the alcohol, it turned pink? Or
Yeah.
CO2 to the alcohol and water? Because I thought the alcohol and water were already together. Wait, no, because the CO2 4 is blue and the COH2O is red pink.
Yeah, the COH2O with the 6, that's when we added the water. That's the formula for when the water and the isopropanol was in it.
Okay. So what did you write for 1A?
I said the mixture of the water and alcohol reacted with the crystal.
Oh, okay.
Okay.